Hello, welcome to Simon's Shed. This video is all about controlling signals by DCC. The signals in question are obviously the Dapol semaphore signals, as you can see, and there are a lot of steps to get through, so let's crack straight on. First, we're going to need some things. The signal. Now because my layout's N-gauge, I'm obviously using the 2mm to the foot scale signals, but Dapol do a 4mm version of these, and as I understand it the wiring's the same, so the same applies. We need a relay. I will go into that in a bit more detail shortly. We're going to need to drill a hole in the baseboard, so 14mm drill bit and a drill to insert the signal. And we have got a bit of soldering to do, so obviously we're going to need some solder, soldering iron and some wire. The first thing we're going to do is simply test the signal. We're going to put DCC to one side for a moment and make sure it works first of all, because there's no point messing about with DCC decoders and addresses if we're not sure the signal actually works. So I've got it clamped to this bit of card, and that will allow you to see there with that nut how it would actually clamp to the baseboard. So obviously this is level with the top of the scenery. This represents the baseboard, and that's how it clamps in, and you can see there's 4 wires. So quite simple. We supply power to the signal, if I can get the wires, with the red and black wires. Now they're very insistent in the instructions that it's 16 volts AC, not DC under any circumstances. So with that in mind, wiggly line means AC, alternating current, and straight line with dots means DC. So we can't use this DC accessory output. To test it, I'm simply going to plug in it straight into my Hornby Select and straight into the track feed, which is AC. So 2 wires to power it. You just power the signal, and then the only other wires are these 2 yellow wires, and that sends the signal down the wires for the signal to actually change. So let me connect it up and we'll give it a try. So you can see all I've done is simply plug the wires, the power wires, straight into the track feed on the controller, and I think you can see that we've got a red LED stop signal. So I'm going to take the other 2 wires, touch them together, and we have a green for go. So that's pretty cool. Every time you touch these wires together, that sends a signal to the signal to change. And I think that is very, very simple and a very elegant solution. Now, what you could do is wire these 2 wires up to a push to make switch, a very simple switch, which just momentarily, when you hold it down, connects these 2 wires, and that's it, job done. If you don't want to bother with DCC, this is a fantastic little signal to use. It looks fantastic to me, and it works very simply, and the wiring is very simple. However, we don't want to make things easy for ourselves. We want to control it via DCC, and that's where it gets a little bit more complicated. Don't panic, I will explain this. I don't like wiring diagrams, mainly because I don't really understand them myself, so I've decided to lay everything out and explain it this way. Hopefully it's clear. So let's start with easy bits. We've got a DCC controller, DCC bus connected to the controller, dropper wires to the track, and DCC feeds into the accessory decoder here. I'm using the ADS8 DCC Concepts accessory decoder. We've got the signal, obviously. Now the signal gets its power, in my case, from the DCC bus, which is powered from this current which is alternating. You can power the signal, so these wires could be connected to any 16 volt AC power source, so you don't have to connect it to the DCC bus. And yes, I can't avoid it any longer. This here is called a relay. Okay, you can think of a relay as like a switch, but obviously a switch, you physically push it to make a connection, and the switch we need for this signal is a push to make switch. There's lots of different types of switches and there's lots of different types of relays, so I'm just going to explain the type of relay for this project. It is a 12 volt DC SPNO single pole, normally open, or it may be called SPST-NO, single pole single throw, normally open. As I say, there's all kinds of other relays, just as there's all kinds of other switches that work in different ways. It's a bit of a nightmare if you try and Google that, because lots and lots of results come up, and there's so many results you don't know which one to actually buy. So the one from Maplin's, which is the product code JH13P, actually definitely works because I've tried it, and they only cost £2.39 I think, so not too bad. So that wire should be there. So essentially what happens is we're going to connect the solenoid output, which gives a quick burst of power, to power our relay. When our relay is NO, which is normally open, so it's like this. When it gets a burst of power, it closes, and that will power the not power, but connect the two yellow wires together. And as soon as that burst of power is gone, it will be open again, so it's normally open. So you must get a normally open relay, is what I'm trying to get at. So the yellow wires from the signal are connected to the two outer pins, which is the switching circuit, and we've got a red wire and a green wire connecting to the other two pins, which is the sort of power circuit of the relay. Now here we've got three connectors on the accessory decoder, but we've only got two pins, so we have to split the red wire in two and connect it to L and R, and the green wire goes to COM. So to explain how that's going to work, there's three states this solenoid output can be in. It can be completely off, so we've got no power going anywhere. It can be left, in which case L and COM will get a burst of power, so the power will go up here, and you can see that it'll go green pin and through this black wire to the red wire to power the two pins. Or it can be R, in which case R and COM get a burst of power, and again it goes up the red wire, green wire. So again, two pins on the relay get the power. So the polarity is changing. That doesn't actually matter, it still activates the switch, closes the connection to the yellow wires, and it still works. It doesn't matter which way round you put the polarity, fortunately. So just to try and clarify a little bit, as you can see, the outermost pins of the relay are the yellow wires, which is where the switch will be closed, and the other two pins here are the red and green. There you go, the red and the green. Green goes to COM, red comes down here and splits off into two and goes to L and R. Right, it's time to drill a big hole through my scenery. First thing to do is check underneath and make sure you're not going to come out on top of any accessory decoders or wiring or wooden beams that are across, and yeah, take it steady. So here goes. Bit of a mess to clean up, but we're through. Okay, just gonna test fit the signal. Goes in nicely, and I think I just might have to trim a bit off of this board at the bottom just to make it fit, and remove the remains of this little bank here to flatten it all out so this is level with the ballast. But yeah, that fits nicely. Okay, I'm now going to solder it all together as I showed in the wiring diagram that wasn't really a diagram. So here goes. So, all I've got to do now is, under the board, connect these to the DCC accessory decoder and connect these to the DCC bus. So I've just tinned the ends of these to make it easier to plug in. So here we are under the baseboard, and you can see the bottom of the signal poking down there. It's worth saying I did wire everything up before putting it through the hole, but if your relay's any bigger than that, you won't be able to do that. You'll have to put it through first and then do the wiring underneath the baseboard somehow, which will be a little bit trickier. So my advice would be get a small relay, and of course don't forget to take this nut off, because that won't go through the hole, obviously, because it needs to be big enough to clamp onto there. So make sure you take that off before you solder the wires, although it does just about fit over this relay. It's a lot easier to take it off first. So all I've got to do now is wire it up into this accessory decoder. Just screw the terminals into there and break into the DCC bus, probably here, to power the signal. Okay, we're done. You can see I've secured the signal to the baseboard with the nut there, broken into the power supply and soldered the wires on there, the power wires to the signal, bit of insulating tape, tidied everything up with cable ties, so the relay's now tied up over here, and I've plugged everything in to the accessory decoder. You will notice these wires, these were a point motor that was plugged into that decoder. I've tried plugging both the point motor and the signal in, and it doesn't work. It doesn't seem to have enough power to trigger both, so I'm going to have to buy another two accessory decoders. You can get one board with two on, so I'll just have to get one of those. I thought you'd be able to do both from the same decoder, but it seems it doesn't work, so that's worth knowing. Right, let's give it a test. Next, we need to program the decoder with a number. To do that, we simply flick the switch on the decoder. That puts it into listening mode, and then it's as easy as whatever you need to do on your DCC system to enter a number, which in this case is just type it in and then press select, and then you simply press, let's press this one, press one of the directions, and it's as easy as that. Right, I'm just going to show you how to program it using the E-Link with some help from Oliver. Say hello, Oliver.
Hello. So I'm going to be running the train and controlling the signal.
So just quickly show you using the E-Link. We're going to go into Trackplan Editor, which is that one. You load your track plan.
Oh, sorry.
Load your track plan and just go signal, choose the type, place it where you want it, wherever you want it, right click, select the controller, try not to knock the camera. The next free number happens to be 68, so I'm going to put that in. Just select the first from the list, which is a Hornby one, but that still works with the DCC concepts controller I'm using, and then save it. So I've put the signal there. Again, I flick the switch to make it listen to the programming mode, and then we simply press the button and it's recognised that, and the signal now works. Thanks, Oliver. So there we are. I've blended it in with a bit of static grass and ballast and so on. The only thing you have to be careful of is make sure you don't get any glue on the little metal rod behind the post, as that obviously has to move up and down to control the signal, so you have to be very careful with that. But other than that, great little signal, and hopefully that explanation all makes sense. So please like, comment and subscribe and all that stuff, and I think I'll leave the final word to Oliver. So what do you think of the new signal?
Good.
Cool.
And bye.